My UV exposure unit project matured nicely. Um, Something is missing. You saw in the last video I actually did some exposure tests, and yeah, the only way to control the thing at the moment is I could press the power button down here, or at the backside. Sorry, earthquake ahead. At the backside, I have that vintage headlight switch, which does not cut the whole power, but controls the MOSFET on the power supply board, switching on and off the UV LED boards. And that's a little bit crude, right? So a little bit of a controller and the user interface would be nice. Now, don't get me wrong. Earthquake ahead again. There would probably be enough space here in front of it to put in one of those rotary electromechanic timer switches that you have, for example, for controlling your appliances. I think they are available from 0 to 50 minutes and 0 to 10 minutes. That would be sufficient, but there's no fun in that, is there? So, instead, I want a really nice user interface, and there I have some problems. Obviously, I have a whole lot of space, unused space, here in the back, but yeah, that would be clumsy. So it should be somewhere in the front. And there my problems start. Because here at the front, everything is kind of curved, and yeah, also down here directly in the front, putting buttons, also a bit clumsy. Yep. I have already these indicator LEDs, which I will reuse. I mean, I reworked the board with SMD LEDs to the best of my abilities, which were not yeah, that good for SMD soldering, my first try. But I have here, if you open that thing up, here there is some flat space. And here you would be able to put in some nice keypad buttons and a tiny little display and so on. And it's enough space. Yeah, if you just look at it. But there's a little caveat. And the caveat comes in form of this little metal support strut, which is limiting the available space on that flat part on the case even more. Yeah, the inside of the case, bottom view, here is the board with the indicator LEDs. Here you can see where the curvature of the case on the top starts, and maybe you can see these tiny lines. There I made with some edding an imprint of that support bar. So the support bar is running here. So all I have left to work with is from here to here at the smallest part, and that's not very much. That's about 14-15 millimeters, so 3/5 of an inch. Not too much. I already breadboarded the keypad I want to use with well, an up, down, obviously for increasing, decreasing something, right, left, for, yeah, I probably have 3 digits, you know, minutes, and 2 digits for seconds, and read store, so I can, yeah, I will use an Arduino as controller, an Arduino Micro to be exact, so can store a value, so every time the thing comes up, yeah, but that's controller stuff. That will be another video. And of course I have run, pause, and stop. Yeah, and it's 9 buttons because yeah, I'm using 6 lines for that keypad, so I can do 9 buttons. So why not? Yeah, and if you want to see how that keypad stuff works, I made a video about that. As always, card link. On the other hand, I have that very, very nice and small OLED display. Yeah, there were, I think it was in some unboxing video, or no, in a mailbag video. Uh, but yeah, getting that to work with the Arduino in a very resource saving way, so just for displaying text. I've also made already a video about that if you're interested in it. Again, card link. However, so that should fit into, what did I say, from the width, 14 millimeters. And yeah, I came up with a layout for that. So that's all that has to go onto that board on the front with the user interface. So 9 switches organized at a 3-row by 3-column keypad. Again, run, pause, stop, left, up, down, right, read, store. And of course the display, which is an I2C. I hope you watched the other video. I put a card and link in. And yeah, this all goes through a 10-pin connector and a flat cable somewhere to the controller, who will probably be placed in the back of the case. Yeah, and then I came up with this layout, and yeah, actually this is, if I remember it right, 16 millimeters. And you remember I said I only have 14 millimeters because before we go into yeah, the curved part where the case is curving down, which is okay because if you look at it from the side, yeah, these surfaces here of the micro switches that will be pressing onto the case probably, or have a little bit space, and the board is below that. So if I have a few millimeters more here, yeah, the curvature is not too big. That should fit just fine. Yeah, here is obviously the OLED display. And yeah, it's all in a very, very small form factor, and I don't need any wire bridges. It will only be a single-sided board. And yeah, but before going ahead, a little reality check never hurts. So this is the same, much smaller. That's actually 1:1. And I will cut that out and will try to fit that, just the paper model, into the case. So if I take the cutout here and I zoom in a little bit, Oh, not a little bit, obviously. Yeah, it should be fitting. You see, yeah, this standoffs here, the whole plastic stuff holding the indicator LED board in place, might get a little in the way because you see the line, yeah, or what's left of it. Yeah, there's maybe a millimeter or yeah, a few dozen thou missing. So yeah, I have to Dremel back this a wee bit, just a wee bit, to get it all in. But otherwise, it looks quite good. Yeah, and also on this side, I have, when I'm mounting it, a little bit careful, yeah, to go a little bit here on the side. Maybe I take the up, down, left, right key here exactly to the center. I don't know. Yeah, but how to mount that? I mean, obviously, I don't. Yeah, I have 3 mounting holes here. These are for M3 screws. And yeah, obviously I don't want to put M3 screws through the case shell. That would be stupid. Instead I do it a little bit different. So on the back of that support strut, I guess I put some with 2 screws here and here, put a little bit of sheet metal, and then the whole thing can be mounted right on that. Okay, so there is some precision cutting action ahead on that sheet metal. I think that's part of an old CD-ROM, but yeah, it's reasonably thick and sturdy. I mean, I'm pressing buttons here, so that should be okay. Yeah, so something like that. There's one problem. The problem is there's no way that I build that layout here on a perf board. I mean, my traces here are 0.5 millimeters or, yeah, 20 thou. But fortunately, as I've proven in the before video, with me holding a stopwatch and actuating the 30-year-old headlight switch in the back, I can expose photosensitized PCB material. I will try it. I will expose that one, and I think it should be pretty doable. I mean, 20 thou. Let's have a look at that one again. As my last video showed, I'm quite capable with that photosensitized PCB material and my exposure unit to do traces easily down to 25 thou or even 12.5 thou. So 20 thou traces should not be a problem. I'm aware that the copper is not completely clean here at the 2.30 mark, but it's clearing up quite well at the 3-minute mark. So maybe I will expose it for 3 minutes 30 seconds this time. Time to cut some board. This is a 100 millimeter by 160 millimeter, if you trust the manufacturer. Euroboard, photosensitized from Bongard, and yeah, I already show you my board is I need in 122 in length, so that's 160 minus 122 minus 0.8 millimeter. That's oops the thickness of my diamond cutting blade here, and half a millimeter as reserve. So I need to cut off at this end 36.7 millimeters. Yeah, let's see how that's working out. So that went really smooth, and yeah, we'll see how that is working out. I feel there's, if this is, I'm not sure if there's a burr. You can see the copper, but yeah. And we are, yeah, 122.2. Yeah, that's okay for me. And in the width, we need 26.5 millimeters. 26.5, so I will do that 2/10 more. 25, sorry, what is it? 26.7. Yeah, give it 2/10, just, in case. Okay, I lost some footage. Shit happens, but yeah, that's the end result, and yeah, the rest I can do with the file, no problem at all. And yeah, it also fits my template perfectly. That's part of the connector. There should be no board material here. Yeah, so mirror template. I clean up a little bit, and then we expose the board. Before exposing the board, we cut our exposure mask, and we already learned it's okay to have it a little bit bigger. So let's tape the exposure mask to the board. That looks about right. Not so much space here at at the edges, but yeah, that's okay. So we're nearing the 3:30 mark. Yeah, I get ready to switch that thing off. And and as you remember from last time, you can't really see anything at that stage. So we have to develop the board, and I will do that quickly because you have already seen that in the last video. If I haven't, yeah, where I tested that card link, wherever. Yeah, we had all of this before, so I need, come on, 5 grams of caustic soda, And yeah, I upgraded the thing, not because of the caustic soda of the lye, because in that concentrations, as I said it in the last video, it's not problematic. What's problematic is single crystals of caustic soda falling onto the floor. Just doing our development solution here. And the last time, I think it was 4 minutes, a little over 4 minutes. Okay, there's my development solution with caustic soda, and cleaned up a bit. And here's my board, and at the moment you see, yeah, absolutely nothing. And yeah, let's put it in there. And I have, can you see that? Yeah, my iPhone. Oh yeah, I can already see something. Yeah, zoom. Yeah, I don't want swamping. Yeah, yeah, I think you can see the structures. Yeah, it seems to work much better this time. I'm at the 2-minute mark. And I think, yeah, maybe a little bit longer. Yeah, maybe I stop the development right now. Okay, sorry, you are out of frame. Yeah, this looks... This looks very good. Okay, putting that upside down, and then we prepare the etching solution. Now, you might have noticed that I changed into gloves, and these are nitrile gloves, not latex gloves. Latex gloves do not really protect you from chemicals, and these nitrile gloves give you some protection, okay? It's not heavy duty, but then the stuff we are using for etching, I'm using for etching, sodium persulfate, is also not heavy duty. I mean, it's in the concentration you need. Sure, a little bit more caustic than the lye. And I need 110 grams. Probably my arm is in the way. 108. 910. Okay. That's enough. So the next problem I have, the etching solution should be at a temperature of about 45 degrees Celsius. And obviously that might be a little bit problem. And here's the trick: if you mix, let's say, tap water, 350 milliliters, and add up to 500 milliliters with boiling water, which I'm getting now, then you are at about 45 degrees. And if you're interested, leave a comment. I'll show you the formula to calculate that for any temperature. Sound might be a little bit off, just a little bit. Ooh. 500 milliliters. Stir it, and let's see where we at up temperature wise. And yeah, we are pretty much at, it's already falling again. It was at 45 degrees. So that's fine. We now add our sodium persulfate. And I won't need that anymore. Yeah, and I will show you that contraption in action just in a second. Yeah. There's some plastic part there. So what this does is shake things a little. Okay, maybe not the best idea, but the only thing I have right now, because this takes quite a while. It's working not that bad, is it? Okay, that was the dad of my shaker, but I think the idea as a prototype is still valid. So I will simply stir the stuff now and then. And temperature is of course quite low, 30 degrees. So I guess this can take a while. So 40 minutes in, temperature 27 degrees, which is far too cold. And yeah, you can see at the edges the copper is disappearing. Almost an hour in, and yeah, temperature's down to 25 degrees. Things are speeding up. 1 hour, 5 minutes, and yeah, 25 degrees. And it's almost done. 2 hours, 12 minutes, and we're almost done. Compared to normally at the right temperature, 30 minutes. Okay, done, done, done. Let's dry that up and see what we have, huh? Oh, no, let me first get rid of that stuff. That stuff, that sodium persulfate, especially now it's a little bit blue because of the copper that has been dissolved in it. You shouldn't put that into, down the drain, because to most organisms that stuff is really toxic. Also to humans, by the way. And if you put that into a bottle, I will show you in a second, that bottle has a little hole in the top because that will develop gas. And if you have a gas-tight bottle, yeah, you're in for a surprise. Yeah, by the way, the shaker contraption I built was obviously not very successful. I think, yeah, some parts here came loose and so it stopped shaking, and yeah, shit happens. I need something. I mean, this was a prototype anyway. I need something better there. Yeah, on second thought, before we go any further, I throw the board into the UV exposure unit for a few minutes, and then I put it back into the developing solution. That way I don't have to bother cleaning up the traces from the photoresist. It will come off naturally. Okay, I just throw that into the caustic soda after I exposed it for another 5 minutes or so. So we just leave it in there for a few minutes and then we rinse it again and then we have a look. Okay, a few minutes passed. I guess whatever was left here of the photoresist should be gone now. Let's dry this up. And yeah, caustic soda, very low concentration. I got rid of the gloves. Yeah. We'll have to have a look at the details, I guess. Yeah, the result is pretty crusty. Maybe it can be salvaged when I mean, there is copper in most all places. If I just tin the stuff. Let's see how that's working out. So I'm not sure if it was I was exposing, sorry, I was exposing 30 seconds longer than I should have. Let's get the other board for comparison, if I can still find it. Oh yeah, here. So yeah, this has the photoresist still on it. And this looks more intact, the photoresist layers. I guess it's a process. Okay, let's try to drill that thingy here, and then we go from there. So, yeah, drilled. And now I clean it up again, and then we apply some, well, not snake oil. The stuff has tradition. Just a second. So we're using some Contact SK10. That's basically a sprayable flux and protection stuff. Let's see what we can do. Yeah, I guess that was the worst trace of them all. And let's see if I can get here some continuity or not. Okay. So from here to here, we have nothing. Can you see where I am? So here we have the first failure. And I wonder if just tinning will help. In fact, it seems it had made wet matters worse. Okay, let's try from the other end. Okay, I can see the problem. Let's try something else. Some silver wire to the rescue. Oh, doesn't look beautiful, but it looks like something. Sorry that was out of the frame. Ah, not too shabby. The next one would be that one. Okay. No. What's the matter here? I think I see a break. Wonderful. Next trace. Wow, I got lucky. Yeah, I guess it was only the outer two traces that were really, really bad. So, in the end, I mean, I have to admit, sorry, doesn't look nice. No, no, it doesn't look nice, but really not. But in the end, there were only one, two, three broken traces. So, yeah. I guess going with the exposure time so high was not the best of my ideas, but yeah, it still survived. And in theory, we can put the parts on now.